Okay, this is section 8.3, the inverse trigonometric functions, and this is page 3. So let's take a look at what we've got here. Number 3 at the top says the inverse sine of square root of 2 over 2. And so what we're asking is for where the sine of x is square root of 2 over 2. And for a minute here, I'm going to write more than we need just so we can make sense of what we've got going on. So sine is positive in quadrant 1 and 2. In quadrant 1, the sine is square root of 2 over 2 at pi over 4. And in quadrant 2, sine of 3 pi over 4 is also positive square root of 2 over 2. Now again, when I say inverse sine of square root of 2 over 2, I don't want to have to choose between two values, which is why this has been restricted. So we only want the value that lies in quadrant 1. And so you'll notice that my page of the notes here has this unit circle at the bottom. Yours does not. That is okay. When we define inverse sine, it goes from negative pi over 2 to pi over 2. And up here in quadrant 1, that's where the sine of x is positive. Down here in quadrant 4, that's where the sine of x is negative. But we hit all possible values of sine between -1 and 1 using those two quadrants. Notice here we got that 0 right in the middle. And so we've wrapped this around the 0. Basically, we want to be able to include 0 easily. So quadrant 1 and 4 makes more sense than trying to use quadrant 2 and 3, which is why we've got this defined over here. Okay, back up. So now we want to know where sine x is negative square root of 2 over 2. Again, in quadrant 3, that is 5 pi over 4. In quadrant 4, that is 7 pi over 4. Notice something though, the range goes negative pi over 2 to pi over 2. Neither of those fall inside that range. Okay, so we're used to using a unit circle with those angle measures being positive. But here in this part of our range, we're looking for negative angle measures. So I'm going to list these as the coterminal angles that go the other direction. And that should not be a 3. What the heck? We got negative pi over 4. Negative 3 pi over 4. The quadrant 3 angle does not fall within our range. That's to be expected, right? We said we want angles in quadrant 1 and 4. And it's a matter of writing it in the correct form for the answer. Your answer has to be listed as an angle between negative pi over 2 and pi over 2. Negative pi over 4 falls within that range. 7 pi over 4 does not. Okay, so up here, inverse sine of square root of 2 over 2 is pi over 4. Inverse sine of negative square root of 2 over 2 is negative pi over 4. On to the next one, number 4, says find the exact value of the expression in degrees without using a calculator. So on our unit circle, we don't have 0.5. We do have this written as 1/2. Okay, so the sine is 1/2 at pi over 6. They don't want it in radians. We want this in degrees. That's 30 degrees. Inverse sine is negative 1/2. In quadrant 4, negative pi over 6, which is negative 30 degrees. Keep in mind that's the exact same angle as a 330 degree angle, which if you're using the unit circle where we've got all those angle measures written in the positive direction. This is coterminal with 330 degrees. Again, 330 degrees is not an acceptable answer because that does not fall within our range. And actually, since we are doing this in degrees, let's fix our range over here so it matches. Negative 90 degrees to 90 degrees. Negative 30 falls within that range. 330 does not. Number 5, arc sine, which is the same as inverse sine. So we are looking for the inverse sine of -1. We want to know what angle has a sine that is -1. That happens at -pi/2 or negative 90 degrees. Arc sine of 2. This means what angle has a sine of 2? We know that's not possible. We know that our values for sine do not go outside that -1 to 1 range. And we can compare here with the domain. The domain of inverse sine is -1 to 1. 2 does not fall in that range. So we have no value there. 6, arc sine of square root of 3/2. So we can take a look at the unit circle and figure out where the sine is, square root of 3/2. That happens in that first quadrant at 60 degrees. Or pi/3, make sure you're comfortable both ways. And then the inverse sine or the arc sine of negative square root of 3/2 is going the opposite direction. Kind of nice with inverse sine. And you see it laid out here that the inverse sine of a positive ratio is going to be the opposite value as the inverse sine of that negative ratio. That's because of the symmetry across the x-axis. You don't always have it set up so that you can find both. But if you are more comfortable working in quadrant 1, you can crank out that quadrant 4 value fairly easily. The domain, just a reminder here, our input values have to be between -1 and 1. Our range, our output values have to be between -pi/2 and pi/2, or -90 degrees to 90 degrees.